All right, so we're going to talk about pH and hydronium or hydrogen ion concentration. Now, as you may recall, when you have a lot of H plus, right, is high, this is a concentration is high, it's more acidic, right? But what's this about the hydronium ion? I've talked about hydrogen ion, but what's a hydronium ion? Well, a hydronium ion is listed on table E. It's the first one, and it is H3O plus. And technically, this is the ion that is higher when you put acid into a solution. And this is what happens. You have an H plus ion plus a water molecule goes to make H3O plus. If you recall, an H plus ion is just a proton, right? So if we were to see that what an H plus ion or a hydronium ion looks like, when I look at the dot structure, if we look at a dot structure of water, we know that oxygen atom has 6 valence electrons, and they're arranged like this. And then hydrogen atoms attach to it with a covalent bond and bring their own electrons. And this is stable because both hydrogen atoms have 2 electrons, valence electrons, and the other one, the oxygen, has 8 valence electrons. So this is nice and stable. However, let's bring a hydrogen, just a proton, it doesn't come with an electron at all, and put it right next to it. Now, because that was a proton that came to this, it gives the entire structure a positive charge, and that's the hydronium ion. Hydrogen ions don't like to stay in solution by themselves. They attach to water molecules. And so when you see that this, you'll see that hydronium ions or hydrogen ions are used interchangeably, which means that you can use either one when you're talking about high acid content. It's essentially the same thing. They equal each other when we're talking about acids. Okay? Now, let's go ahead and look at how we can relate this to pH. pH stands for the power of hydrogen I believe it does. And so we've done this a little bit already. If there's a hydrogen concentration or an H3 concentration, H3O plus concentration of 0.1 molar, this is a pH of 1. And you might be like, that's a really small value, and that is true. That is a very low concentration. But you don't need a lot of H plus ions in solution in order to be very acidic. An H plus ion concentration, or an H3O plus concentration of 0.0 molar. Now we're less acidic, right? Because we have the concentration is 10 times less than that other one. This is a pH of 2. And you might see a pattern going on here, right? Each 10 times decrease in concentration changes the pH by a value of 1. And so the formula for this is negative log base 10 of the H plus or the H3O plus concentration. That's what pH is. Now, we haven't talked this year about something called equilibrium. But it turns out if you put more H plus ions in water, right, more H plus ions in solution will cause a decrease in any OH minus ion concentration. Why might that be? That's because H plus ions plus OH minus ions react very readily to make H2O. So if there's any OH minus ions in the water, it's going to cause them to be decreased because H plus ions are going to attach them and make water. And so there's an interesting relationship between the concentration of H plus ions and OH minus ions. And if concentration is given by square brackets, so the concentration of H plus ions plus the concentration of OH minus ions in water is always equal to 1 times 10 to the negative 14. That's just a relationship that exists. So if you have more H plus ions, you have to have less OH minus ions in the water in order to equal that constant. Right, so for example, if we have an OH or an H plus ion concentration of 0.01, wait a minute, hold on a second. All right, so I screwed this up. It's multiplied, So these two are multiplied together. And so we could find the OH minus concentration. We can use the fact that superscripts are multiplied. So I could go like this. I could just put this in scientific notation. Minus 2, and then OH. Negative 14. And so this OH concentration is 1 times 10 to the negative 12. All right, now I was screwing this up because the pH, we have pH, right? It was pH is equal to negative log of the H plus concentration, or the H3 hydronium concentration. But we can also say the POH is equal to the negative log of the OH minus concentration. And this is where I was messing it up. pH plus POH equals 14 all the time. So as the pH goes up, the POH goes down. As the POH goes up, the pH goes down. So that's the relationship between those. Who's heard of POH before? It's it's not used as often, but it's basically telling you how much OH minus is in the solution. And OH minus is also on here. It's called a hydroxide ion. So you should be familiar with that if they use that terminology in a question. And that is the relationship between POH and OH. Realize that when you change an amount, a pH amount, then you are changing by a factor of 10. So, let me just talk to you about this. So if we go from a pH value of 3 to 5, how many times more is the hydronium ion, seriously, just got disconnected. How many times more is the hydronium ion concentration in how many more times more do we have? Well, every time we change from one to the other, so if we change from 3 to 4, it's times 4, or times 10. Actually, it's divided by because we're decreasing. And if we go to 5, it's divided by 10 again. So that's dividing by 100. Right? So 3 has That's 100 times more than 5 because we changed the unit twice. All right. And that's it for that.